A teacher gave a test whose results are approximately a normal curve. The mean is 76 and the standard deviation is 8. The teacher wishes to give A's to the top 8%, F's to the bottom 8%, and grade a B to the next 20%, and D's similarly to the next 20% on the bottom, and C's to everyone that's left. So let's think about what we're doing here. We have approximately a normal distribution here. We're saying to the top 8% and the bottom 8% we're going to give A's and F's. So that means this area over here, if that's 0.08, these are the F's. If this area over here is 0.08, then these are the A's. Okay. The next 20% are going to be B's and D's. So I'm going to take the next 20% here. This is 0.2, whatever. Yeah, whatever, I'll call it 0.20. These are going to be D's. And this 20% over here, 0.20, those are B's. And all other students get C's. So C's would be this range here. All right. So we want to find the grade range for a B. So we want to figure out, okay, if somebody's aiming to get a B, what are the upper and lower scores for getting the B? Well, let's see. I have areas. I don't know what this area is right now, but I could figure that out. Let's see. I have 0.8 there, 0.8 there, 0.2 there, 0.2 there. And this C here, that's everything else. So let's figure out what's accounted for so far. 0.08 plus 0.08 plus 0.2 plus 0.2 is, we have 56% of the total area accounted for, which means that this area, the remaining area, must be 0.44. Now, the reason I'm doing this is because I'm wanting to figure out what the area to the left of this cutoff is. So I don't know what this cutoff is, the lower cutoff for a B, but I can now say the area to the left is 0.2 or 0.08 plus 0.2 plus 0.44. 0.08 plus 0.2 plus 0.44. 72% of the students are this grade or less. So I have a total area to the left, and I'm looking for a cutoff, which means I want to use inverse norm. I want 0.72 to be the area to the left. And I want my mean, well, I already know the mean here is 76, and my standard deviation is 8. So my inverse norm, 0.72. Scoot this over. 0.72, 76, 8. So that means a score of 80.66 is going to be the lower cutoff. This is not 80.66% because this, the mean score was 76, not 76%. Maybe they got 76 points out of a total of, I don't know, 80. I don't know exactly what the scale was on this 76, so I don't want to go ahead and say that these are out of 100 or anything like that. The score was 76. The lower bound of this, the mean score was 76. The lower bound of my B's is now going to be 80.66. The upper bound of my B's, well, again, we're going to do this inverse norm here. But in this case, I want 92% of the area to be to the left. I could either figure that out by adding all these values up, including that 0.2, so just adding to this, or realizing that I have a 0.08 right here, and I'm talking about the complement of that. So 0.92, 76, 0.8, my mean and my standard deviation are still the same numbers. I'm going to just press second enter so I don't have to retype all of that, and just change this to a 9. So I get 87.24. So that means if this teacher wanted to give grades out the way that's described here, then B's would be given to the score range between 80.66 and 70.24.